Hi, well, I'm Allison Gardner. I just want to tell you a little bit about myself before I move on to the main talk. I got my PhD when I was 50, so I'm an early career researcher, as I was saying earlier on. When I was raising my daughters, I got a little bit bored as they're older, and I did a master's degree and discovered this whole new field called bioinformatics that had developed. I was a molecular biologist to begin with, and I really liked it. And so I thought I'd like to do a PhD. And somebody said to me, "Oh, Alison," I said, "you'll never do a PhD part-time in distance learning," because I was in Spain at the time. "Never tell me I can't do something." So anyway, I got offered PhD from Edinburgh or Manchester, and I chose Manchester. And in my interview for Manchester University, I remember one of the interviewers was sitting there. "Hi, Alison, do you have a Linux machine?" And a Linux machine? I was like, "No, I don't think so." "Do you mean, do I have Linux on my laptop?" And I go, "Yeah, I was doing." I didn't ever call it a Linux machine. And I thought, oh, for heaven's sakes, I hated him the entirety of my PhD. But I got accepted. It was to develop an algorithm to predict mutations. When I said yes to that PhD, I could not code a line. I could not even do hello world. But I said yes. And I did a quick course, and I self-taught myself through my PhD, a lot of crying, "Oh, am I going to do artificial intelligence? Oh, God!" And did it, managed to get through. My husband hated it, because I suddenly started developing and going away and doing some time at university, getting a lot of confidence, and it got to the point of, "Alison, it's either the PhD or me." So one PhD and a divorce later, here I am. And yay, well read. But during that PhD, I discovered a real issue about data quality rather than data quantity and big data. And I started to get very doubtful about this enthusiasm for AI and for tech as the solve-all. So this is what I'm going to tell you about. I'm going to tell you about how bias can be built into machine algorithms to form discrimination, how that bias is built in, and why that bias is built in because of a lack of diversity. And I'm going to focus on why there are not women in the field of tech, particularly AI. And I'm going to completely disagree with the concept of the leaky pipeline. The pipeline is not leaking. Women are being forced out of it, and I'll tell you why that happened. So I'm very grumpy. So some examples of where we can get bias in tech. So this was the first one. I know the team who developed Tay. This was a chatbot that they released on Twitter, and it was a learning algorithm to learn from its environment. So within 24 hours of being on Twitter and learning from the feedback it was getting, it turned into this Hitler-loving sex robot. And it was awful, and it was so bad that they had to take themselves down. I forgot to set my timer off, so I'm going to have to watch you. It was awful, and they were so embarrassed. Another one was Google with their photo tagging. And they found that they were actually photo tagging people with black faces as gorillas. And when this was flagged up by one of their tech guys, so this is ridiculous, they tried to fix it, found that they couldn't fix it. So now what they've done is now you can't tag gorillas as gorillas. They've removed gorillas because it was the only way they could fix it. So that's what that headline says. So that it's so endemic. Then there's these are coming very popular now, these child abuse prediction algorithms. So they started off in the States, a very sort of, well-written algorithm, and Algeni, I'm probably pronouncing that wrong, by an academic, open source, but she admits that it's biased because the data that they use to build it on comes primarily from poor families. So it's biased against those in poverty. Now, evidence shows that children can be abused and neglected regardless of class and economic status. But unfortunately, the rich do not get brought to the attention of social services the way that the poor do. So the data that this algorithm is built on is biased. And we have 5 councils in the UK now have had private companies develop algorithms, and they're utilising them. And the answer is, don't worry, it relieves the social workers of all that worry about all those meetings about deciding whether to do something, and they can go and do what they do best and work with the families. No, I'm also a councillor in my local council, and that is not what will happen. What will happen is, instead of having 6 social workers around a table discussing a case, what they'll do is they'll have 3. Because they won't need 6 because they're using this algorithm. And you'll end up not only reducing in staff, but you'll also end up de-skilling as well, which is what's happened in the States. We've also had things like in fraud detection in UCAS within the UK. If you're black, your university application is 21 more times more likely to be flagged up as fraudulent, so making it harder for you to access university. This was self-driving cars, with this big one in AI ethics about, who do you run over? And they found that it's actually more likely to run over a black person than a white person, this study claims. So that was a new one that's just recently come out. Within the financial sector, loans, mortgage, all based on algorithms. And again, inbuilt bias into those. So people who are poor or who have got negative social status, for example, are less likely to get the loans and the mortgages and the preferential treatment. And so this, again, further builds this inequality that you get. And of course, Amazon's possibly the better known one, that their recruitment algorithm that they had actually was biased against women. And this happens quite a lot with these recruitments. So be very careful if you think that tech will solve a lot of these problems. Early on this morning about unconscious bias, I heard about how, all of these ways of, choosing orchestra, women who are playing in the orchestra, and they do them by blind auditions. So, well, maybe if we could design an algorithm to detect the best musical player, it won't matter if they're male or female, but it could be built on faulty data. So you have to be very careful of all of these things. I'm not really negative. There are some really, really good AI apps out there, or algorithms out there. So this is one to detect skin cancer. They found that it's 95% correct compared to 87.5% of dermatologists, which sounds fantastic, doesn't it? Okay, one thing I will point out, there's another article in Nature that looked at a different algorithm that could actually diagnose many illnesses. And they found the big headlines was, algorithm predicts or diagnoses diseases better than doctors, until you look at the data. And what it does is it diagnoses diseases better than trainee doctors, but not as better as experienced senior doctors. So the question that you have is, if they go, oh, great, what we'll do is we'll use those algorithms to do the diagnosing, and we'll train the doctors on using that. Are we going to never get to the point of the old senior doctors who could diagnose better than the algorithm? Are we going to limit how good we get and de-skill our doctors in how we train? And algorithms like this aren't perfect. So they can go wrong, again, on the data that they have. If your data set that you've done all your analysis on was built, from data from a particular country, so the UK, and is biased for white skin, you're going to get less quality for black skin diagnosis. And again, you're going to get health inequalities building in. So when you start using these algorithms, you need to ask those questions. You need to ask about the metrics. What was your data set like? Here's another example. This is a very famous one. Joy Bullin-Winnie and Timnit Gebru did this about facial recognition. And they found that there was, with various big organisations, that IBM's, for example, pretty good on male faces, 0.3% error rate, on female faces, 34.7%. And some of the data sets that have been built for some of these facial recognitions are so biased, 70 to 80% white and 70 to 80% male, except when they want them to be slightly different, and I'll come to that in a second. But before I move on, I'm talking about data sets and algorithms, so a very quick explainer. Do not ever fall foul of the black box argument. Oh, we can't explain our algorithm, it's a black box, it's all very important, you know, we can't reveal it to you. You don't even need to know about that. Your data, huge data sets, is always dirty. 20%, well, 80% of a data scientist's time will be spent cleaning that data, getting rid of all the incomplete data sets and then processing it so that the algorithm can understand it. So turning a yes and a no into a 1 and a 0, or a 0 and a 1, depending on how I want to define it. Then we've got to feature select. So of all of these categories that we're going to do, which ones are we going to put through our algorithm? Which ones are more important? Who makes that decision? Statistics and humans, not the algorithm. And then we might weight it. Depending on the algorithm, we can actually say some features are more important and more relevant than others. Then we shove it through the algorithm, the machine learning, and then when we get our result out, there's more stuff that we do. We look at our metrics. How many false positives do we have? How many false negatives? Where do we want our cutoff to make that prediction? What do we want to reduce? What's the most risky? Is putting an innocent person in prison more risky than releasing a violent person out into society? Where am I going to put my cut-offs? Which brings me to a very famous case. And 9 minutes. Oh my goodness, I'm halfway through. So this is Compass. And Compass actually was brought out as whether you should put somebody in prison or not. And it was found by ProPublica said it's biased. It's really biased against male and black men. Okay? North Point said, no, it isn't. It's absolutely, we've got the metrics, we've got the evidence. It's not biased. Here it is. And the problem was it depended on the definition of fairness that you used. So again, the metrics aren't perfect. And I would also say, be very careful about this over-reliance on algorithms and thinking that they are perfect. That it's actually only about 65% accurate, is Compass. And it's actually no more accurate than a very simple model made of 2 characteristics compared to Compass's 137. And it's just as accurate if you just look at was it age and previous convictions. And if you also got a load of people around, so I pick 6 of you from this audience, go, right, I want you to decide whether we should put that person in prison or not, you would be as accurate as that algorithm that they're spending hundreds of thousands on. So they are not perfect. So again, know how accurate your algorithm is. It is not the quick fix that you think. So a lot of these are really, really sort of crazy issues. How can we allow this machine bias to be built in and this faulty data and this biased data sets and nobody ever think to ask, what's your proportion there? And another little thing that you need to do, algorithms can cheat. So this is a classic one for detecting hip fractures from an image detecting. You think that's fairly benign. But what the algorithm learnt to do was to define by the actual patient's age and the machine that it used to do the imaging. Because if it was a mobile machine, that it gave the impression, well, that person is not mobile, can't come to hospital, they must be really ill, so we're going to predict that as a fracture. It ignored all the personal data about the person at all in the image. And they do cheat. Another one for quizzes, how it was designed to answer quizzes and it had to get this high response rate. And what the algorithm did is it went and it found the answer file that was buried elsewhere deep in the program, deleted it so it always got 100% accuracy. They cheat. So let's carry on. Why have we got to this point? Well, it's because there is a lack of diversity in the development process, and inclusivity as well is really important. So from identifying the type of problem we want to solve with tech, all the way through to developing it and then evaluating it, you can start building in unconscious bias because you do not have diverse teams. And if you are starting to produce algorithms that we are using within society to determine very important things, that is going to embed discrimination and inequality in our society as we enter the 4th industrial revolution. So I ask for you to think about cynicism. So with 5 minutes to go, how have we led to this situation of a lack of diversity? Right, we lack women. proof that we lack women. So this was a work by Element AI and Wired, and they sort of did some analysis. And they found, for example, that Google AI research, there are 21% women in tech. In AI, only 10%. So AI is worse than tech. Facebook, 22% of, in tech, 15% in AI. And overall, it comes to about 12%. Worrying, isn't it, when we're getting these really important algorithms being developed and utilised, and yet we have this limit of women in tech. And I'm just focusing on women now, but it's wider as well. It's very worrying. And we're not going to get any better. This was also from the same level of research, and this is the amount of researchers. I know, and this is just from 4,000 researchers who attended the 3 key conferences. And this was their evaluation of how many were women and how many were men. Now, you can say, well, that's just a measure of how many women can get to conferences. But even that in itself tells you something. And it's not quite correct, because I know Virginia Dignam, who is an amazing AI researcher, is in Sweden. So it's not perfect. Okay, but these are the people that we are hoping to be trained, to be producing our algorithms for us. And it's so limited. So how did we get to this stage? And why is it getting worse? And all of the innovations and code clubs and projects that we're doing to try and encourage women into tech, actually, we're getting worse. Where in the other STEM fields, it's getting better. And this is a Western issue as well, in the UK and the States in particular. It doesn't happen elsewhere. There's an interesting question to look at. And what happened around about this time? 1984. What was special about then? Loads of different reasons. But before then, just before I talk about 1984, just really important to remember, originally, when coding started and programming was invented, it was a female field. 30 to 50% were females. Fantastic history of women in coding. So from Ada Lovelace, who wrote the very first computer program, to Grace Hopper, who developed COBOL and the type of programming language that we use today, so we don't have to learn to machine code, to the people who did the Colossus programmers in Bletchley Park in the Second World War, to the first electronic computer, ENIAC, female coders. Interestingly, the ENIAC ladies were not invited to the celebratory meal when it was actually produced. They were left out. The actual programmers they did not invite. Imagine that happening nowadays. And it was sold as the computer girls. This lovely machine grade thing. It was, really exciting. It was female. But then something happened. Suddenly, it got to the point of going, hey, this has taken off, this programming computer business. This is turning into quite a lucrative profession. So the men moved in. As the respect and need for programmers rose and the pay, men became more interested in the field, and then they started to redefine the field. Rather than this lowly machine grade thing that you couldn't get promoted from, suddenly it became an executive level career. And to boost the field's prestige, they started having professional associations, pushing the educational requirements that benefited men over women and the skills that men at school might have learned, and discouraging the hiring of women. It was active, and certainly within the recruitment within the UK, and I recommend Mari Hick's book to look at how it was a deliberate decision by the UK civil service and how they were going to develop the next white heat of technology. They started to introduce aptitude tests with job candidates. So this is in the 60s and 70s. Ranking candidates on masculinized skills deliberately. Answers to the tests were circulated amongst male-only group fraternities. So this is how women were forced out of it. They started to use personality profiles because two psychologists said that it was this particular trait who didn't like antisocial tendencies. They were creating this nerd image even then, and they're disinterested in people. It was fake. Oh, I'm going back, sorry. And 1984 was when the Game Boys and Nintendo consoles came out, and they started marketing it to men and boys. So this is how it got changed, and we haven't got better yet. And about 45% of women in set fields, but particularly tech, will leave within the first year because it's a hostile environment still, because that's how the field has been built. We're still getting issues like women can't do tech. And currently, there's a big a hoo-ha going around in the UK because there was a letter in the Times from the CERN physicist who said women can't do physics, and they gave him that push. And so we need to change the culture. The culture isn't built. So we need to change how code is taught in schools, how we recruit university students, how we recruit into jobs, which is what you're talking about, change the workplace culture, change the marketing and imaging of tech, and really just cut the bullshit. We need to be honest that this is a deliberately hostile environment to women. And we need to create the environment where it becomes a requirement that we stop this attitude. So I'm working on introducing regulation for algorithms based upon GDPR, algorithmic impact assessments, algorithm audits, and certification and AI fairness stamps. And this will require diverse and inclusive teams in the development process. And so, again, because I'm run out of time now, so I won't spend too much long on this, but this is what we're going to be coming towards. This is where we'll go. So if you're introducing AI into your business, be thinking that you can't just introduce it and think it's a cure-all. You're going to be expected to have some level of ethical production going on. So this is AI Now's example, so an algorithmic impact assessment, AI auditing, the certification, citizens panels, regulation and legislation is going to come forward. And they're all going to be used in utilising the GDPR as well. This is what I'm working with in the UK and with the government at the moment to see how we can bring that in. So yay, GDPR, thank you for that. And various organisations such as IEEE are working on this to develop the standards which I work on in algorithmic bias, and we're talking about diversity. So with my network that I've started, Women Leading in AI, so what we're campaigning for is building requirement in diverse teams and ethics panels for AI certification. Fairness certification and trust marks will be given a competitive edge. So a company that says, right, I'm developing this algorithm and it's got a trust mark, so you can trust me, I as a counsellor, I'm going to procure that algorithm over one that hasn't gone through it because it won't have that endemic bias built into it. They'll have tried to work it out. And that will be a profit incentive for companies, and hopefully what we will do by doing that profit incentive, we'll have fair algorithms, but maybe we will force back the change in the tech community, in the tech culture that is less hostile to women, because now they're going to need us back because it's going to cost them if they don't have us. Okay, and I'm going to leave it there because I've way overrun, and thank you for your attention.